All right, let's dive right in. We're talking about power electronics simulation today. That absolutely crucial step in designing pretty much everything that powers our modern world. Okay, picture this. You're an engineer, you've got this amazing idea for a new power converter. But how do you actually test it? How do you push it to its limits and get it just right without, all the smoke and sparks, without blowing up expensive real world parts? Well, the answer is kind of simple, but really, really powerful. You build it, you test it, you break it, and you perfect it, all in a virtual world. You simulate it first. And that is where the star of our show comes in, Plex. The best way to think about it? It's your digital workbench. It's this amazing space built from the ground up just for the unique puzzles of power electronics. So, what's with the name, Plex? It stands for Piecewise Linear Electrical Circuit Simulation. Now, that sounds like a mouthful, but that name is the secret sauce. It's all about simplifying complex stuff into a bunch of straight lines. And because it does that, it can simulate the super fast on-off switching you see everywhere in power electronics at lightning speed. So you might be asking, why Plex? Why not something else? Well, it all comes down to one word: focus. It is laser focused on switching circuits. We're talking MOSFETs, diodes, the whole 9 yards. That piecewise linear trick we just mentioned, it means it's just fast, blazingly fast. And it doesn't just do the electrical side. It brings the control system into the same space, which is exactly why it's the go-to for things like motor drives or buck converters. Seriously, it's just like having this perfect digital toolbox. No more digging through drawers for a specific resistor. You're just grabbing whatever component you need right from the library browser. Okay, enough talk. Let's get our hands dirty and actually build something. We're going to start with a simple RLC network. Think of it as the hello world for circuit simulation. It's perfect for showing you just how easy and intuitive this whole thing is. Step 1. We need parts. So you pop open that library browser, our digital toolbox, and you literally just drag and drop. Grab a DC voltage source, a resistor, an inductor, and a capacitor, and just pull them right onto your workspace. Done. All right, now we wire it all up. And this is cool. As you hover your mouse over a terminal, the cursor actually changes. It's like it's telling you, hey, I'm ready to draw wire. You just click, drag to the next spot, and boom, they're connected. It's just so simple. Okay, so we have a circuit, but it doesn't mean anything yet. We need to give it real-world values. All you do is double-click on a component and its properties pop up. So for this, let's say 10 volts for the source and maybe 100 microfarads for the capacitor. This is the moment our digital sketch starts to become a real physical thing. But how do we actually see what's happening inside? We can't just look at it. We need a measurement tool. So we're going to grab a scope from the library, wire it up across our capacitor, and that becomes our window. It's how we peek inside and see what the circuit is actually doing. Okay, one quick but super important thing before we hit go. We need to talk about the solver. Just think of it as the brains of the operation, the math engine that's doing all the hard work behind the scenes. Plex gives you options here. You can use a variable step solver, which is great for getting super high accuracy, or a fixed step solver, which is absolutely essential if you plan on doing real-time testing later on. All right, the moment of truth. Our circuit is built, our values are in, the scope is connected. This is it. It's time for the magic. This is that aha moment where the static drawing on our screen is about to come to life. So let's bring this thing to life. And there it is. A quick double click on the scope and up pops our results. What we're seeing here is a perfect snapshot, a single moment in time, say 25 milliseconds in. And we can see right away our capacitor is already up to around 8.5 volts. Getting that kind of instant feedback, it's just so powerful. But a picture's great, but it's not the whole story. The real magic of simulation is digging in and getting the hard data, the precise numbers. So inside that scope window, we can use these things called cursors. You just place these little markers on the graph and bam, you get exact values at those specific points. Want to know the voltage difference between two moments? Easy. Need to calculate something more complex, like the RMS value over a certain time? The scope does it for you. It's fantastic. Okay, so that was the basic hello world with an RLC circuit. But that's really just scratching the surface. The true power of Plex comes from its more advanced features. So let's take a quick peek at what else this digital workbench has up its sleeve. Here's a big one: heat. Power electronics gets hot, right? While Plex lets you do detailed thermal modeling. You can actually simulate the losses from your semiconductors. And the benefit there is huge. You can literally predict if a part is going to overheat and figure out your cooling strategy before you've even ordered a single physical component. Now this is an absolute game changer. You can design and perfect your control system right here in Plex. And then, get this, it will automatically generate the C code for you. The benefit is just massive. You can take that code and deploy it directly onto a real microcontroller. It's the ultimate bridge between simulation and reality. And it doesn't stop there. Plex's is packed with powerful analysis tools. You can do really complex stuff like AC sweeps to check frequency response, or loop gain analysis to make sure your control system is actually stable. These are things that would normally take pages and pages of math, and it just automates it for you. So when you put all of this together, you start to see the bigger picture. Plex isn't just about electrical circuits. It's a true multi-domain tool. You're modeling the electrical side, the control system, the heat, the magnetics, even the mechanical parts, all in one integrated environment. You're not just seeing one piece of the puzzle, you're seeing the whole system. And really, that brings us full circle. It doesn't matter if you're starting out with a tiny circuit or designing a massive, complex system. Simulation is, without a doubt, the key to modern, efficient, and successful engineering design. Think about it. This removes the biggest barriers, cost and risk. All that's left is what you can imagine. So I'll leave you with this question. Now that you can simulate just about anything, what are you going to build first?